Thank you, Glenn, for the introduction. My name is Emanuel Villa, or Villa, whatever. I am originally from Mexico. I've been in the US for 16 years. And that's probably all I'm going to share about me. You can go to LinkedIn and then see the rest. So I like to start with a quote from Rudyard Kipling. I keep 6 honest serving men. They told me all I knew. Their names are what and why and when and how and where and who. And I love that quote because that has guided me so much on pretty much every project I'm working on when it's related to data. So this is not about this. So the title of the presentation is Anatomy of a Data Pipeline, but it's not this, okay? So if you're expecting to see this, you're in the wrong room. What this is about is data pipeline. So let's start by just defining what do we mean. So data, a little bit of Roman history, comes from the Latin da. Those who speak Spanish know that da means give, and dare is to give. And that comes from philosophy. So it's not like a dare, but it was kind of like, I'm going to give you 2 pieces of information. I'm going to give you 2 premises, and then you're going to give me a conclusion. So you probably have heard something like this. Premise A, every man is moral. Premise B, Emanuel is a man. So the conclusion is Emanuel is moral. There you go. So you just did a dare. So you just did this. So datum was, those 2 premises were each a datum, and data is just the plural of that. And mind you, the story of this is that every time you see data was to get to a conclusion. It was just not like flowers are yellow and the sun is bright. Well, yeah, but that doesn't get me anywhere, right? So all the time that data was used, it was to get to a conclusion. Now, in computing terms, what is the information that is transformed just for efficient movement or processing? And at the end of the day, that comes down to ones and zeros that are somewhere stored on a piece of infrastructure. And then pipelines refers to the movement on transportation and transformation sometimes of things like gas, water, oil, whatever. And in this case, we're going to move data around. So in computing, it refers to a linear sequence of modules that perform operations to get the end result of a big operation. Oh, by the way, feel free to just ask questions anytime. So it's a sequence of elements that do a process in which the output of one element is usually the input of the next element. And they're usually memory intensive. Is something we call a data buffer. So that's really just the definition of data pipeline on bullets. As you can see on this diagram, there's always an ingestion, some sort of movement, and then it goes to somewhere where there's going to be some analysis. There can be transformation, there can be storage, there can be neither, but there's always movement. And we're going to go through some of these examples as we go on the presentation. So to start, let's talk about other pipelines hopefully everybody here is familiar with. A blood draw and taxes. So everybody here has get a blood lab. Yeah, right? And everybody has done taxes, I hope. Okay. No illegal. Okay, good. So thinking about that quote of the Rudyard Kipling, what, why, how, who, where, what can you tell me about blood work? So let's just start on the why. So why do we have blood works? Yes. So usually the why is you're sick and the doctor doesn't know what it is, and he's gonna get your blood work, or you're gonna have an annual checkup and then they take your lipids and all that stuff, right? So that's the why. Now how that happens? You get an appointment. Yes, yes. You get an appointment and then you show up on the appointment any time of the day? No, right? You usually show up, schedule in the morning, and what? No what? No food. Yeah, so there are some requirements to get the blood work, right? And then they draw the blood with a syringe. They usually add something, right? You probably don't see this, but they actually add an anticoagulant. And then say they send that to the lab does all the analysis, and then what happens at the very end?
The results are encoded.
The results are in, yeah. And what happens to the blood? They discard it. So in this case, in this data pipeline, the end product gets discarded, but the analysis is kept, right? Mm-hmm. So keep that in mind as we go through more examples. Now, taxes. So how do we do taxes? So first off, can we do taxes anytime? No, right? It's usually just once a year. Once a year. So there's a waiting period to do the taxes. Then you gather all your papers, and then you decide TurboTax or whatever, or you can decide give it to somebody who knows what he's doing, and then you get your return to the IRS, submit it, and then they accept it, right? Pretty simple, yeah. Sounds simple, but that's it. So anyway, so those two data pipelines or pipelines have a process, have requirements, have ends, right? So just take that into account. So here is some of the things that we said. You need an appointment for the lab work. Something is added to the blood. You dispose of the blood at the end. And the taxes you submit to your IRS and you wait for acceptance. So yeah, pretty easy. So when I was in grad school on biomedical engineering, my second medical related course was medical physiology. And the doctor who was teaching us assumed that we knew anatomy. It was hell on wheels. So I'm not gonna get you through that hell. So we're gonna see anatomy first, and then we're gonna see how it works, okay? So these are the elements of a data pipeline. We have the origin, where the data starts, destination, where it's going. We have a data flow that has processing in big, bright green, like this one. We have storage in black. And then we have a sort of workflow, which is the one that orchestrates the whole thing. And we have hopefully a monitoring piece that checks the health of this system. And then all this sits on top of some sort of technology. Now, technology here I'm using just in the general sense. So it's a technology. I'm not saying all this sits on top of Databricks or all this sits on top of Google, whatever. So just technology in the general sense. So technology is just the infrastructure where your ones and zeros are, pretty much. So that's it. So kind of like, if you're gonna put this on a digestive system, this is the mouth, and the destination, well, is the toilet. So start with the origin. Is the point at which can I take this off? Yes. There you go. Yeah, now you can read. Is the point at which the data enters the pipeline. So it can be APIs, sensors, databases, whatever it is. And I refer those as data sources, or can be storage as well. Now, storage is also a data source, but these are usually not stored. So that's why I make that division. But it's at the end of the day, it's just your source where the data is coming from. Oh, wait, I forgot something here. Yeah. How do I go to the previous slide? No? Oh, maybe I need to click on it. There you go. So there's one thing here that I'm not sure it should be added. And I will love to get anybody's input with somebody of you who has more experience. Data governance. So I'm not sure if data governance deserves its own thing or what. And I'm just not that experienced on data governance to know where to put it yet. But if somebody knows, I'd love to have a conversation. Okay. So yeah, somebody said something.
In data source,
Yes.
looks like one of the important things, usually using some kind of raw files, text, spreadsheets. That's
Oh yeah, I have files over here. But yeah.
storage, but for data source, I read data from data source.
Oh yes, yes. So these storage are your source.
Got it.
So these terms kind of mixed up.
Got
I
it.
just divided these because these you can't store per se. Yeah. Okay, thank you. So destination is the toilet where things are being delivered. So it's pretty similar to the previous slide, right? You have some sort of storage, database, data lake, golden record on a master data repository, something like that, files or some sort of sandbox, or it can go directly to an application, usually a reporting application like Tableau or Power BI or whatever it is. You can actually write directly to those servers or those applications. The data flow is just the sequence of the processes that are going to happen. And it has the processing and the storage, if needed, again. And the storage is pretty much just defined where we persist the data at some point of time during that pipeline. And the processing is just what happens to the data. So we ingest it, we transform it, we clean it, we filter, we append things to it, or we review it, we do QA, we monitor, all that. The workflow, again, the workflow is just like the management piece of all this. I put this job, task, process, upstream and downstream, just because that's the lingo used in case you're not familiar. So usually somebody will say, will refer to a process as the whole process or to a process as a piece of the process. Now, being very technical, usually a task is just like a little thing that have like the task of filtering or the task of consolidating or the task of the standard for this data. And the job is usually more than one task, but many people uses these terms interchangeably. So a job can be just one thing, but it can be many things. So, but I put that there just for reference. And upstream and downstream, anybody want to take a jab at that? Upstream again versus downstream?
Whether it happens before or after sequence.
Perfect, yes. So pretty much, if you're at step 2, you can go upstream to step 1. If you're on step 5, upstream is 1, 2, 3, and 4. So there's no upstream at the beginning and there's no downstream at the end. So pretty much that's what it is.
Emanuel, there's a question on Zoom saying, what is the role, it's going back a little bit. What is the role of storage? I noticed the arrows only point into the storage box. So how do you retrieve it?
Oh, yes, correct. Yeah, I guess I need to change that arrow to go both directions. Yeah, good catch. Thank you, whoever said that. So yeah, the storage is pretty much just where we persist the data or where we read the data to continue the process. So in this case, I am trying to say that this black square is kind of like a staging area for the data, like a temporary staging area for the data. Yes, thank you. Let me make a note of that.
Just to store some temporary state.
Yes, correct.
So it can be both. So you could be aggregating the source, but you might have a use case where you do multiple different aggregations. So you store it and
Depends on business case, right?
Yes, yes. So where were we? Oh, yeah. We talk about this here. Monitoring is just, this is one of the pieces that I, in my experience, most commonly forget about. Like I build the data pipeline and then I forget about it without setting any alerts in place or monitoring in place. So don't forget this because it's gonna save you a lot of nightmares. But it's pretty much the element or elements that keep in check that the pipeline is working as it's supposed to.
Do you
And
have any favorite tools for doing the monitoring?
for monitoring, I like, what's the name? Great Expectations. I like it. And I also like visuals, like just once the data is on, if the data is on a staging area, then you can put some visuals on top so that you can see quickly variations and all that stuff.
Mhm.
Yeah.
Because in my experience, that's the hardest part because the data is always changing. And you generally would set alerts or rules based on certain cases, but there will always be a case that is.
Yes,
better
yes.
than-
Yeah, we're gonna talk about that too, so hold that thought. And then the technology piece, it's all your infrastructure, databases, all your ETL, utility tools, your automation tools, your visualization, everything. Every tool you use is gonna be a piece of technology. This ETLT, I saw it just like few months ago.
Yeah, this I don't know.
So it's pretty much extract, some transform, then load, and then transform again. That's pretty much what it is. So it's like, just imagine the extract you get from a file, and then that file has money, and then money has the last two digits as cents, but doesn't have a dot. So you kind of transform it, but not a whole. And then you put it on your actually staging where you actually transform it to do the analysis that you wanted. So that's kind of the idea of this ETLT.
Thank you.
Yeah, I kind of laughed too when I saw it the first time. And here is the whole thing again. So again, these arrows should probably go two directions. Thank you to whoever said that. Yes.
What's the difference between a data pipeline and a data integration? Is an integration just like one step in the pipeline? Or is that even a real term?
No, so integration refers more to the process of getting data from multiple areas into one as a whole.
Mhm.
So, and that requires pipelines to do that job. That's pretty much the.
I would say even more clear. The data pipelines we can specify in two main groups. One, data ingestion, and second one, data transformation. The data ingestion are responsible to take data from different various sources, what we saw in previous slides related to data source. And the data ingestion is responsible to take different formats and store in common format. And data transformation is responsible to transform the original data into business definitions, business vision that help to understand this data for data science, for data consumptions related to destinations such as reporting system and so on. And the transformation take a lot of business logic for the company.
Does that answer your
Right?
question? Yeah. So now let's talk about the physiology. So how it works. How do we, somebody tells you, make me this data pipeline, how do you go about it? So you start in the toilet. So you start at the end. So you need to know why they need this data. and where is needed. So is it going to a database? Is it going directly to an application? And that's gonna dictate a lot about how you decide about building this pipeline. And I'm gonna go through some examples, so just keep it quiet for now. So they can be a data warehouse. And some of the questions you ask is like, okay, so what class of storage is this? So do you need just files, or this is going to a database? If it's going to a database, then very likely it has to fit some sort of model. And that's why you need to know. If it's files, you might have to follow some rules, but sometimes you don't. Sometimes they say, no, just give me the files as they come and then I'll figure it out. Is this data need to be normalized or denormalized? Now, this is very technical, so anybody don't know what this is, normalized versus denormalized?
Go ahead.
Okay, so normalized will be a model in which each, I don't want to say the word table, but each entity has its own file or cabinet separate from the others. So you have a set of files that have patient data, and you have in one file just the demographics. You have in another file just the diagnosis. You have in another file just the procedures. You have in another file just the labs, things like that. So that will be a denormalized. Normalized, sorry, a normalized. Denormalized is you will have one file that has demographics, labs, and procedures done. So everything is in one big file. So denormalized files or tables usually have duplicate information in some of the rows. But that can be an advantage. So don't get too fixated that everything has to be normalized. Actually, doesn't. Timeliness. So if this is coming from a replica, then we probably need to wait until that replica finishes so that we get the data, just in the taxes, right? We have to wait until the year ends so we can start. And usually when there's a replica, when they're doing the replica, they don't want you to read the database because create a replica is kind of like intense. It's an intense process. So if you're going to have some process that runs on that server, they ask you to do it at another time. So that's why it's important to ask about the time that they want you to do this. And then just if this is real time, so is it streaming or is it batch? So it means like it's in batches, that's the main implant. If it's going to a report, you might not need to store the data. And you need to ask if it's okay to pre-aggregate the data. So this refers to a problem I had recently in which they were asking for some sort of data, and then I asked, so what you're doing with data? And they say, oh, we're going some basic statistics on them. So my thought was, well, I can just send you the whole data. And they were like, no, but the whole data is a lot. And we don't want to do that. I'm like, but if you're going to do statistics, you need the whole data because the average of the average is not the average, right? So it's like, okay, so if it's sums, it might be okay because, you know, sums, just sums. But if you know that they're going to perform some sort of operation, then you need to straight just say, if you don't like it, I'm sorry, but you have to deal with that because in order to be accurate, you need the whole data. And the need to store it. So also recently, a person was calling an API that give a JSON file, and then he was doing reports on Power BI directly. And I asked, so do you need the historical pools? And they said, no, we just need that call. So it was probably one of the fastest pipelines I ever did because Power BI can set up calls to APIs directly. And that's it. So there's no need to store it. Just do it in one thing and just do it in one sit, pretty much. So really cool. So that's why you start at the end. Then step 2. So you're in the toilet. Now you go back to the beginning. So now you need to understand where the data is coming from. So is this a replica again? Is this transactional data? Is this a data lake? If you have a data lake, hopefully you can get to the data catalog that tells you what's there. And it's not a data swamp. Is this an API call? Is it a messaging system? And all that stuff. And again, the databases, you might need a script to get, or you might need a whole copy of the database. Is the data event-based, so it's a stream, or is it batch, which is just entity like database or files? And also take into account the time and the possibly latency in the origin to get to the destination. Again, just like in the taxes. So you have to wait for some things to happen before getting the data or not. What happens usually on streaming data is that you set up windows. Can be event-based, so every time I see this data, then that's a window of your data, and then you analyze that chunk. Or it can be, no, I just need a time window. So the data is coming, and then you say, okay, every 10 seconds, just give me this data, and then you analyze every 10 seconds. And you can do staggered windows. You can do a lot of things on streaming data. There's a lot of variety on that, but you need to understand what they're trying to do and how it's coming for you to decide how to do that.
Most of the data related to this ingestion about event-driven approach that you described. One of the interesting case, anomaly detection, when somebody decided to take your credit card and start making some transactions. And in banking system, they're using event-driven approach to detect some not standard behavior of user. And because of event-driven approach, they can easily detect and inform by SMS message that you are using this transaction or not. This is one of the interesting cases for timeless distribution.
Yeah, thank you. I'm gonna add that to the next time I say this presentation.
So, I have a question.
Yeah.
So, for me, usually it's a lot about how the data is also generated. Because once you understand how the data is being generated, you can actually understand what transformations needs to actually follow for it to exist properly.
Oh yeah, yeah, absolutely too. Yeah, yeah. Okay. Welcome. Thanks. So you understand the end, you understand the beginning. Now is time to get to the actual heart of it. So you design the data flow. This is really what's going to take probably most of your time. And so it's not possible that it to consist of only storage and no processes, but it is possible that it's only a process and not storage. So I hope that makes sense. So it's like, you cannot have a pipeline that just stores things without doing anything. I guess just backups, but anyway. When all inputs are not ready at the same time, then you need some sort of staging, storage area, where you put everything together and then you transform it there. And that's part also of the design of the workflow. If you have intermediates, so if you have this huge data pipeline and it has several steps, consider doing, instead of one huge data pipeline, consider breaking data into more pipelines and then have each of those middle storage areas be one destination. So pretty much that's the takeaway here. Decide on a pattern like ETL, ELT, batch, stream, and many more, and an architectural pattern. So this is going to be linear. So like in a sequence. So I do this, then I do this, then I do this, then I do this. Or can I do it in parallel? Can I do multiple things at the same time, pretty much, that's part of it. And lambda and kappa, I'm not very familiar with, but I'll tell you what it is when I get to that slide, but don't ask me too much about it. So, yeah, so this is one example of what I was trying to say. So if you have an intermediate place where you're gonna store, consider then saying, okay, then I'm gonna make two pipelines. In that way, you kind of follow these microservices type of thing in which if somebody for some reason needs access to this middle area for analysis or check or monitoring or whatever, you already have it there. And it's not a whole, it doesn't interrupt this or that, but it's there. This is on the pattern. So we have the most simple pipeline you can get is I have an origin and I just do a roll load to the destination. So that's pretty much the simplest pipeline you can get. Then you add something. So I have transactions, but I need to add a dot to the money transaction because there's no dot. So you do that transformation and then you load. In this case, it's like, I'm referring here to if it's a data store or a file where the origin is coming from. If it's a streaming, then you apply something else, but pretty much is the same transform load. It's just you parse differently, filter differently, just because it's a whole stream of data and you need to decide on your analytic window. Then the other pattern is you extract, you load, and then on your destination, you apply some sort of transformation for the analysis that is going to happen. So this is the ELT one. And then this is the ETLT one. So again, you extract it, you kind of transform it, then you load it, and then you transform it. So this is probably among the most common, actually, because this main transformation and this main load to the destination, imagine this is your production system, right? But rarely people in production system gets the raw data as it is. They usually aggregate or they usually do something, right, to it. So that's a small transformation that happens at the application level. So that's what this is referring to.
That pattern would also be very good if you were having multiple data sources.
Yes.
Because you could do this, you load it to the same area, but have one common final transform.
Yep.
at the end.
And I think it's the next picture, actually. Yes. So you have multiple sources. Now going to some sort of staging area where you transform, and then you go into a data warehouse, and then you apply your analytics platform on top of that data warehouse. Oh.
One of the interesting case in current market that most related to cloud, that's all the pipelines run in cloud and usually they're using ETL. Load and then transform. It's meaning that between source and transform, they load original files and store where in cloud as is original. And then they're making some transformation part. So this is more popular at the moment in the market. I think so.
Yeah.
Because what you're demonstrating, this is for on-premises system usually using because you have database on your in the office. You can call transaction from your Oracle or Postgres, and the timeline for calling is easily in short period of time. But for clouds, it's problem with network bandwidth between source and transformation part.
Yeah, absolutely. Yeah. Thank you. And then the next one I think is the streaming. No, so this is pretty much what you were, I think, saying, which you have the sources and you load it and you transform it.
Absolutely.
And then you analyze. This is just the an example of a batch operation. So you have sources, and then you apply your operations by an amount of time, or like every month or every week or every file or whatever your batch size is. That's it. And then your business intelligence or analysis on top of that. This is an example of a stream processing pipeline. So you have your IoT or your sensors, whatever, which give you real-time events. And then you have some sort of processing engine that defines your windows. And then you push that to the real-time analytics platform. So a very common example of this is if you have a Fitbit, right? So the Fitbit is in real time sending or storing things in there. And then there's a trigger when you open your app that kind of does all the analysis up to real time at that time. This is another example of what we think when we say linear. So each operation happens after one, or if it's possible, you apply the different operations to the same data, and then at the end you consolidate. Now, parallel processing is this is a way to do parallel processing. So each line does a process, but also parallel processing can refer to each line does the same process, but to a different source. So imagine if you're in the cloud, you can set up Lambda functions that apply to files as they come in. So you dump 10 files and the Lambda executes 10 times. So that's a parallel process but it's the same process to 10 different files, but it's in parallel. It's not one file and then the other and then the other. So it can refer to different processes or the same process, but in different sources. And then this is the Lambda Kappa thing. Is used for streaming, and it pretty much just refers to the Lambda has a storage layer and the speed layer go into a batch. So it allows you to do batch and stream views. And Kappa is only for streaming, pretty much. That's really the only difference. Okay, so after you understand the toilet, the food, the workflow, then you define how you're gonna store that data. Just talk about the volume, so you don't run out of space. Although now, if you're in the cloud and it's files, you can just point to a bucket and don't worry about the volume anymore. You worry about the structure, about the format, again, because probably there's a model that you have to fit in. If you have to retain those original files or not, for how long, what's the frequency of that data coming on? Are we going to use this data for something else? Are there any governance constraints, especially on like financial data and medical data? There's a lot of that. Security, privacy. If you have to comply with something like a regulation that tells you, no, you have to retain this data forever, then that's a regulation. There's nothing you can do around it. And also, do you need a backup? So do you want, in case everything fails, do you want the data somewhere else so that you can rebuild it? Pretty much, that's the fault tolerance piece. So all that gets defined on your storage. And then you focus on the processes. So these little pieces of tasks that you're gonna perform on the data as it comes in. So it's just the ingestion, the persistent, again, refers to the storage, the transformation, or the delivery. The ingestion can be, again, a database replication, can be an export from somewhere, can be a messaging queue, a stack, streaming. Just quickly, anybody want to take a jab at what's the difference between a queue and a stack?
Q is first in, first out stack.
Yes, so stack. So stack. Then when I take, what did I stack?
So it's people first in, first out.
Yeah, and Q is as they come in, they come out. Pretty much. That's the difference. And then on the persistency and delivery, it's pretty much the same thing. And then the transformation piece, which is probably the heart of the pipeline. If you're going to improve the data, enrich the data, format the data, clean the data, and all that. So these are some of the processes that we do on data. Most of them are self-explanatory, but the ones that cause the most confusion is probably these two. Standardization and conforming. So anybody want to try to guess what's the difference between these two? I won't judge.
Anyone on Zoom? We haven't heard it a whole lot from
A
Zoom.
lot of things was released from different areas related to data governance, data transformation, orchestrations part. And we can take different variations here.
So standard usually refers to my standard is my date is YYYYMMDD, right? My money comes with 2 digits for cents. My social security number doesn't have dashes. So things like that. That's my standard. Conforming is in this file, routing number refers to what in this file refers to ABA. So they're called different, but it's the same thing. So it's that cross-linking, I guess is the word. Yeah, so it's like what means here is the same mean over here. That's conforming.
I think you also wanted to say that it's the data from original type of data, such as integer, right? We'll be able to transform in standard integer in your data pipeline system, right?
Yes, that will be a,
Supports standard data types.
yes. So what will sampling be?
When you have too much data, you figure out and you want to analyze it, then it's hard to use all of the data sometimes, so you figure out how to sample it in a way where you can get approximate but right result.
Yep.
As close as possible.
Yep, so you have a lot of data and you want to just kind of glance at it, you take a sample of that data randomly, and then you figure it out.
It will depend on the use case of whether it's random or not.
Well, yeah. Sorting, sequencing, that's pretty obvious. Aggregation, we talk about it too, so it's a pre-operation on it.
What do you mean by derivation?
By what?
Derivation.
Oh, yes, derivation. So I have height and weight, but I need a BMI. So I'm deriving a new data
Okay.
from other data. So that's derivation.
Okay.
Yeah. Anything else?
Do you typically do anything with, for example, lineage in a data pipeline? So you're putting together source 1, 2, 3, so you're also maybe putting in information about where this data came.
Mhm.
Encryption as well, meaning that your data are related to social security number. So it have to be encrypted because it's sensitive data. And even doesn't help masking here.
Yeah.
I think lineage would be important, specifically within like date time, because you have to find out when an event happens at a certain location. Because there are different time zones throughout like the US, for example. So if you try to get everything on the time it was taken, is it at the same time throughout everything, or is it at that time of that location?
I don't know.
So like whenever you ask like when does the New Year's ball out? Technically midnight, but if you're asking the Nashville, 11 p.m. So it does depend on the lineage of the data.
Oh, yeah, I see what you mean.
This is help you, installing ISO standard that you can store your date time in, the core standard that will help you detect your time zone with date, minutes, hours, milliseconds, and so on and so forth.
Yeah, so you will set up a standard that says,
I always thought lineage was more of a information.
But lineage, this is one of the important things. Giving you example for data science, the critical things when they start develop some model, they spend more than 80% of time to understand what the data from where it came. And lineage, what our colleague mentioned, this is important thing to understand from what the data come, how the data was transformed, and so on.
yeah, that, I guess that will be part of just the documentation of what's happening.
For classical databases, you are right. But for more modern system, data lakehouse, warehouses, business wants to go right now to understand from where the data come.
So is that part of data governance as well, that lineage
That's right.
piece? Okay. Yeah, I don't know much about it.
Modular orchestration and transformation frameworks like DBT or I don't know, giving the example, AWS Glue, for example, they able to provide that lineage, and the lineage is just represent the original metadata of data source and original data of destination, and comparison per column or per attributes from where to where it's mapping. And with this metadata, you can create a graph where you can see your data source from, let's say, SQL Server, and data come from all your pipelines, this transformation, aggregation, blah, 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 and that you will see this data in, I don't know, in Tableau or Power BI.
So it's like the roadmap of
Yes.
what happened to the piece of data that
Yes.
you're,
Mhm.
okay, I
Yes.
see. Thank you. Yeah.
And this is requirements, one of the requirements of CCPA and GDPR.
Mhm, okay. Yeah, I didn't know that. Okay. Anything else?
Yeah, what's assembly and construction?
Oh, yeah, so that's pretty much like similar to this, but not through a operation, more like take the first two letters of the last name plus a sequence number plus whatever, and then that will be my ID for something else. So it refers just to like assembling things. Yeah. Okay, good, we're good. Next, design the workflow. So this is again that management piece of the whole thing. And this is where you actually start really more interacting with the technology you're using to design it. So this is where your DBT comes in, all that stuff. So it manages the sequence of the processes and the whole process, or part of the process. And again, process, job, task, it's like interchangeable. So most important takeaway is if there's an operation that you need to be done before you start the next one, you need to check that actually is done. And you cannot continue until that's done. And downstream, if there's something that depends on it, then you have to check for that one to be done and so forth. So it's just checking the dependencies pretty much. Yes.
It's more like a high level question about that. I've never used any of the tools for data pipelining. I've just kind of made a simple data pipeline using different Python scripts and stuff. So is that what those are for? Is for like, you're not able to run different steps unless the dependencies have been completed? Or,
Yeah, so, I mean, you're pretty much doing everything in one tool. and
Yeah.
There's nothing wrong with that.
Yeah.
Yeah, so,
so what's the other stuff?
it's just like, so imagine you would like to, let me just go back. So your process includes some standard on a field, and then you don't care about some records, so you filter that. And then you might be deriving something new, and you can do that in one Python script, right? But if you want to do a Python script that does each thing, and I'm just oversimplifying your question, right? So if you want a Python script that does the standard, and then another Python script that does the filtering, and then another Python script that does the derivation, then you need something to orchestrate that piece. And that's your workflow,
Giving you
pretty
example
much.
in practice. If we're talking about Python, one of the interesting open source platform, Apache Airflow. The Airflow, this is exactly workflow orchestration that help you to take your bench of your tasks, clean data, prepare data, transform data, prepare data for specific reports, and you can manage this bench of tasks by your ordering that help you to manage your logic. And all the tasks you can manage through the jobs. I want to run this batch of tasks in specific period of time or by triggering and so on and so forth. And the Airflow, this is one of the de facto popular tool in Python world.
Yep, pretty much.
Okay. In the previous slide, so master here is one of the processes in the transformation, but I've seen it be at its own step altogether, and that I think belongs to the larger sense to the data governance. And examples when I worked for the state in the pharmacy department, narcotics prescriptions, mental health diagnosis had to be mapped. Especially when you have vendors who are going to go into very sensitive data. So that was something that was a completely separate step altogether. And some of the people who designed the pipeline were not allowed to even see that data. And we had to have another team that can keep up on find all of that stuff to actually take the just that.
Yep.
So in a lot of cases, it might not be just a process, but maybe a standard.
Yeah, so that one will be an example of something like this, right?
Yeah.
So you have just a masking piece that loads it somewhere, and then from here, you pretty much start another,
Right.
yeah, another. Where is it? No. Yeah. So you have one that just does the masking and puts it somewhere. And then your team takes it from here and then does something. Yeah, that would be one.
There is some missing part for security, what you mentioned, unmasking and encryption. Usually, the data has come in original data stored as is. and nobody have access. But for transformations part, for data science, they want you to see and play with this data, and they're using masking functionality. But for storing all this data, they fully encrypt in file and in internal file. It's meaning that each that lines of rows in your, let's say, CSV or bar keys and so on, encrypted. And even if you're trying to read this, you cannot without encryption keys.
Okay. And then finally, don't forget your monitoring, as I have done. So this is just the piece. This is your great expectations, your visualization on top of that staging area, your, I think, what's the name? Oh my gosh. AWS logs, CloudWatch, thank you. Yeah, so all those alerts, all that infrastructure that gets you alerted when something happens.
And I like someone responsible.
Yes, so that's actually one of the most important pieces. So it's not just like, oh, we have an alert and then nobody cares. You have to have someone that knows what to do when that alert comes up.
By the way, in Azure, Microsoft Azure,
Yes.
it's calling simple Azure Monitor.
Yeah, and I think on Google was called something stack. I forgot. Anyway, on my experience, and this is just personal experience, there's no gospel here. If you get, let's say you get things month by month, and then September you got something, October, November, if the variation from September to October is 10 to 15% the variation from October to November, then it's usually okay. In my experience, might be different, but in my experience that's what I've seen. And then, oh yeah, so what needs to be monitored? Your space, if you're on a server, is very important. I have run out of space as well. Amount of records per amount of time, especially if you're on a streaming platform. And just the memory that you don't run out of juice, pretty much.
May I give some more interesting case monitoring? In your slide, you are mentioning all around environments, but we're talking about data and data itself. Important monitoring alerts of data quality or data validation score. That's meaning that the data that's come and transformed is incorrect. This is important information for data, but not that you don't have space. This is alerts related to infrastructure parts, for DevOps, for data engineering part. But the data, who touched data, who changed data, who accesses data, this is important to monitor this part. And monitoring are responsible for security area and as well for data governance and for data quality that I mentioned in the beginning. This is the areas where monitoring is mandatory.
Oh yeah. Again, that got data governance piece that I need to put in. Okay.
I have a question.
Yes.
You mentioned that like you did not do what they have a story to share there?
On the monitoring, it have been lots of them, but most of them have been on the memory of the server that we just ran out of space, and then that breaks the interface. So yeah, you can. The chat tools nowadays like Slack and Teams and all that make these very easily. So you just kind of put webhooks in place that you can call when something happens. So yeah. Sometimes the alerts don't need to be addressed immediately, but and they can wait to the next morning. So you don't need like somebody calling you endlessly to take care of things, but things that you need to take care of the next day. And then finally, all this is on top of the technology. So this is where you decide which technology you're going to use. There's the right tool for the right job, the okay tool for the okay job, and the wrong tool for the wrong job. So I had to fix a pipeline once when somebody was reading from SQL, putting on an Excel file, then put it on Access. And then from Access was sending to Power BI. So why? I mean, you can just go straight to SQL from Power BI. I have no idea why. But, yeah, right. I guess they just wanted experience to all these things, but yeah. So technology is constantly moving. So if you're in charge of a team, I encourage you to consider name someone or to be like you 1-2 hours a week, just look what's out there, what's new, go to conferences, go to things like this, just like stay up to date. And if you are already on somewhere, try to stay in that zone. So if you are already on Google Cloud, try to stay on Google Cloud unless you really need to go out. And I am an advocate for open source tools, but that's not necessary. You cannot do cloud open source, I guess. So, yeah. So in summary, you start on why the data is needed, and when and how and all that. You go back to the origin to understand the process. Then you design your data flow. You set up your storage steps, your processing steps. You design your workflow to manage all those steps. And then you put in place your monitoring and you decide on the technology. Pretty easy. You can just remember this. Just remember, that's someone. Okay.
Thank you.
And oh yeah, so this is from a book, The Fundamentals of Data Engineering. It goes from like the raw data all the way to most advanced things that you can do with data like AI. And pretty much data pipelines usually work below this red line. So sometimes they aggregate, sometimes they do things like this. But most of the time, this is what we do on a pipeline. These are my references, and that's it. Yeah, no question.